So in this question, we have to calculate the maximum value of 3x square plus 9x plus 17 divided by 3x square plus 9x plus 7, where x belong to the set of real numbers. All right. So if we assume that f of x is equal to 3x square plus 9x plus 17 divided by 3x square plus 9x plus 7, and x belong to the set of real numbers, then we have to find out f of x maximum. All right. Now, as you can see in the numerator and the denominator, we have a common term 3x square plus 9x. So I'm going to write f of x as 3x square plus 9x plus 7 plus 10 divided by 3x square plus 9x plus 7. Now, if I split the numerator, what I will get is 1 plus 10 divided by 3x square plus 9x plus 7. In order to calculate the maximum value of f of x, we have to minimize this denominator, which is 3x square plus 9x plus 7. Now, what is the minimum value of 3x square plus 9x plus 7? We know that this curve 3x square plus 9x plus 7 is going to be a parabola opening upwards. So the minimum value is going to lie at the vertex, and it is given by minus d by 4a. All right. Now what is negative d by 4a? It is equal to 4ac minus b square divided by 4a. So the quadratic that we have here is 3x square plus 9x plus 7, and we have to calculate negative d by 4a, or I would say 4ac minus b square divided by 4a. Now if I put the value of a as 3, b as 9 and c as 7, what I will get is 4 times 3 times 7 minus 81 divided by 4 times 3, and this is equal to 12 which is 12 times 7, which is 84 minus 81 divided by 4 multiplied by 3, which is equal to 1 by 4. All right. So we have found out minimum value of 3x square plus 9x plus 7, which is equal to 1 by 4. So f of x maximum will be equal to 1 plus 10 divided by 1 by 4, which is equal to 1 plus 40, and that is equal to 41. All right. All we had to do was minimize the denominator, minimize 3x square plus 9x plus 7 to find out the maximum value of f of x. And the value that we got here is 41, which is same as our option B here. So in this question, we have been given that 5r square are the lengths of the sides of a triangle. Then r cannot be equal to which of these 4 values. All right. So we have to consider a triangle ABC with these lengths. Now a triangle is only possible if sum of 2 sides is greater than the third side. Now we have 3 possible combination of sum of 2 sides. So the first combination is 5 plus 5r, and it should be greater than 5r square. The second combination is 5r plus 5r square, and it should be greater than 5. And the third combination is 5r square plus 5, and it should be greater than 5r. Now these 3 combinations should hold true together, should be true simultaneously. That means at the end, when we solve for these 3 inequalities, we will get 3 intervals. At the end, we have to take the intersection of these 3 intervals. All right. So the intervals that we will get after solving 1, 2 and 3, we have to take their intersection. All right. Starting from the first, which is 5 plus 5r is greater than 5r square. As you can see, 5 is a positive number. I can cancel it out from the complete inequality. We'll get r square minus r minus 1 less than 0. Alright, if we calculate the value of d for r square minus r minus 1, we get d is equal to negative 1 square minus 4 times 1 times negative 1, which is equal to 1 plus 4 and is equal to 5. If d is equal to 5, then one root would be minus of negative 1 plus root 5 divided by 2, and the other root would be minus of negative 1 minus root 5 divided by 2. That means one factor is going to be r minus 1 plus root 5 divided by 2, and the other factor is going to be r minus 1 minus root 5 divided by 2, and the product of these two factors is less than 0. That means r belongs to the interval 1 minus root 5 divided by 2, comma 1 plus root 5 divided by 2. Alright, as 5r is the length of a side of a triangle, r cannot be less than 0. That means we have to start from 0 and go up till 1 plus root 5 divided by 2. We have got one interval in r. Alright, now let's talk about the second inequality, which is 5r plus 5r square is greater than 5. Again, 5 is a positive number. Cancelling out from the complete inequality, we get r square plus r minus 1 greater than 0. If we calculate the value of d for r square plus r minus 1, we get d is equal to 1 square minus 4 times 1 times negative 1, which is equal to 1 plus 4, which is 5. Alright, now one root would be minus 1 plus root 5 divided by 2, and the other root would be minus 1 minus root 5 divided by 2. So the two factors that we will get is r minus 1 minus root 5 divided by 2 multiplied by r minus 1 plus root 5 divided by 2. Alright, now product of these two factors is greater than 0. That means r belong to the interval minus infinity to minus 1 minus root 5 divided by 2 union minus 1 plus root 5 divided by 2 to infinity. Now we have to reject this term here, or I would say this interval here, because r cannot be negative. So r belongs to the interval minus 1 plus root 5 divided by 2 to infinity. Alright, now taking the third inequality, which is 5r square plus 5 is greater than 5r, which can be written as r square minus r plus 1 greater than 0. If I calculate d for this expression r square minus r plus 1, I'll get d is equal to minus 1 square minus 4 times 1 times 1, which is equal to 1 minus 4 and is equal to minus 3. D is less than 0. Coefficient of r square is 1 greater than 0. That means this term here, r square minus r plus 1, will always be greater than 0. That means r belong to the set of positive real numbers. Alright, so we had three inequalities. We got three intervals in r. The first interval is r belong to the set of, so first interval is r belong to 0, 1 plus root 5 divided by 2. The second interval is r belong to the interval 1 minus root 5 minus 1 plus root 5 divided by 2 to infinity. And the third interval is r belong to the interval r plus, alright, set of positive real numbers. All I have to do is now take their intersection. When I take their intersection, I'll get r belonging to the interval minus 1 plus root 5 divided by 2 to 1 plus root 5 divided by 2. Now if I put approximate value of root 5 as 2.25, what I'll get is 0.6 something going to till 1 plus root 5 divided by 2 is approximately 1 point something, alright. So starting from 0 point something going till 1 point something, so r belongs to this interval. If r belongs to this interval, then we can clearly say that option D does not lie in this interval, and hence the answer to this question is option D. Now in this question we have been given a quadratic equation c minus 5 times x square minus 2cx plus c minus 4 is equal to 0. It's also given that we have to consider a set which contains all the integral values of c such that one root of the given quadratic equation lies in the interval 0, 2 and the other root lies in the interval 2, 3. Then finally, we have to find out the elements, the number of elements in set S. All right. So this is a quadratic equation given to us in the question. Now for this quadratic equation to be defined, the coefficient of x square, which is c minus 5, should not be equal to 0, or we can say that c should not be equal to 5. All right. Now if I divide the complete equation with c minus 5, what I'll get is x square minus 2c divided by c minus 5 times x plus c minus 4 divided by c minus 5 is equal to 0. Now this new equation has two roots, alpha and beta, such that alpha is less than beta. If alpha is less than beta, then we can say that alpha lies in the interval 0, 2 and beta lies in the interval 2, 3. Now these two inequalities can be combined to give us this, where alpha lies between 0 and 2 and beta lies between 2 and 3. Now if I plot the graph for f of x defined as x square minus 2c divided by c minus 5 times x plus c minus 4 divided by c minus 5, this is what I will get. All right. From here we can say that f of 0 is greater than 0, f of 2 is less than 0, f of 3 is greater than 0, and d greater than 0. Basically, we have 4 conditions and we have to solve for those 4 conditions to finally find out the interval in which c lies, and then eventually find out the number of integral values of c. All right. So this is the function into consideration, f of x. And the first condition that we have to calculate is f of 0 greater than 0. So we have, the first condition is f of 0 greater than 0. What I will get from here is c minus 4 divided by c minus 5 greater than 0. As you can see, we have 2 critical points. That's correct, 4 and 5. Now we are going to take a number which is greater than 5, say for example 6. Put in the expression c minus 4 divided by c minus 5. What we'll get is 6 minus 4 divided by 6 minus 5, which is equal to 2 and greater than 0. That means we'll start our wavy curve with the positive. Alright, we start our wavy curve with positive. Around 5 it will change to negative. Around 4 it will again change to positive. And the final curve that we will get is this. And keeping in mind that both 4 and 5 are not included, that means C belong to the interval minus infinity to 4 union 5 to infinity, for which this expression should be greater than 0. Alright. Now let's talk about the second inequality or the second condition, which is f of 2 is less than 0. Now what is f of 2? It's 4 minus 4c divided by c minus 5 plus c minus 4 divided by c minus 5. Now if I simplify this by taking LCM, what I'll get is 4c minus 20 minus 4c plus c minus 4 whole divided by c minus 5, and this should be less than 0. Alright, now if I simplify this further, what I get is c minus 24 divided by c minus 5 is less than 0. Again, we have 2 critical points. That's correct, 5 and 24. If we plot them on the number line, this is how it will look. Now we are going to take a number which is greater than 24, say for example 25. Put the value of c in the expression c minus 24 divided by c minus 5. What we'll get is 25 minus 24 divided by 25 minus 5, which is equal to 1 by 20, and this is greater than 0. That means we are going to start our wavy curve with the positive sign. About 24 it will change to negative. About 5 it will change from negative to positive, and this is the final curve that we will get. Alright, now one thing we have to keep in mind that both 5 and 24 are not included, so we will have open circle here. Now we want that region where the expression is less than 0, so we can say that C belong to the interval 5, 24. Alright, so we have solved for 2 conditions. The first condition is f of 0 is greater than 0, and the second condition is f of 2 less than 0. Now the third condition that we are going to solve for is f of 3 greater than 0. Now what is f of 3? It's 9 minus 6c divided by c minus 5 plus c minus 4 divided by c minus 5, and this should be greater than 0. All right. Now if I take LCM and simplify it further, what I get is 9c minus 45 minus 6c plus c minus 4 whole divided by c minus 5 is greater than 0, which simplifies to give us 4c minus 49 divided by c minus 5, and this is greater than 0. As you can see, there are two critical points. That's correct, 49 by 4 and 5. If you plot them on the number line, this is how it will look. Now we are going to take any value which is greater than 49 by 4. Say for example 13. If we put the value of c as 13 in the expression 4c minus 49 divided by c minus 5, what I'll get is 4 times 13 minus 49 divided by 13 minus 5, which is clearly greater than 0. Alright, if it is greater than 0, that means we'll start our wavy curve with the positive sign. About 49 by 4, it will change to negative. About 5, it will again change to positive. Now the final wavy curve that we will get is this. And important thing to note is both 5 and 49 by 4 will not be included. Now the interval for which the given expression is greater than 0 would be C belong to the interval minus infinity to 5 union 49 by 4 to infinity. Alright. Now the fourth and the final condition, which is D greater than 0. We know D is equal to B square minus 4AC. So what we will get is B square minus 4AC is greater than 0. Now if we put the values of B, A and C from the f of x, what we will get is 4c square divided by c minus 5 the whole square minus 4 times 1, which is 4, times c minus 4 divided by c minus 5, and this is greater than 0. Now if I take LCM, what I'll get is c minus 5 the whole square, and if I simplify this, what I'll get is 4c square minus 4c square plus 36c minus 80 divided by c minus 5 the whole square is greater than 0. Alright, now we know that c minus 5 the whole square will be a positive number. So if we multiply the complete inequality with c minus 5 the whole square, the inequality sign will not change. And the final thing that we will get is 4c square minus 4c square plus 36c minus 80 is greater than 0. Now these two terms will cancel each other and we will get c is greater than 80 by 36, or we can say that c is greater than 20 by 9. C is greater than 20 by 9. We have only one critical point, 20 by 9, which is also not included. And the region that we are looking for is C greater than 20 by 9. So we can say C belong to the interval 20 by 9 to infinity. So we have solved for 4 conditions. We got 4 intervals of C. Alright, this is the interval we got from first condition, this is the interval we got from second condition, this is the interval we got from third, and this is the interval we got from the fourth condition. Now we have to take the intersection of all these 4 intervals. So how are we going to do that? We are going to plot these intervals on the number line and find for the overlapping region. So if I plot them on the number line, if I plot the first interval, this is how it will look. If I plot the second interval, this is how it will look. And if I plot the third interval, this is the region. And if I plot the fourth interval, this is the region. Alright, as you can see that this region right here between 49 by 4 and 24 is the region which is common or which is overlapping for all these 4 intervals. So C belongs to the interval 49 by 4 to 24, open at both 49 by 4 and 24. Now we are looking for the integral values of C. That means S will be equal to 13, 14 going up till 23, and the number of elements in the set S will be equal to 11 from 13 to 23. Hence we can say that option C is the correct answer to this question. So in this question, we have to find out the number of real roots of the equation given by x plus 1 multiplied by x plus 2 multiplied by x plus 3 multiplied by x plus 4 equal to 120. Alright, so this is the equation given to us in the question and we have to find out the number of real roots of this given equation. What I'll do here is multiply x plus 1 with x plus 4 and x plus 2 with x plus 3. When I multiply x plus 1 with x plus 4, what I'll get is x square plus 5x plus 4, and when I multiply x plus 2 with x plus 3, what I'll get is x square plus 5x plus 6, and their product is equal to 120. Alright, now if I put x square plus 5x as t in this equation, what I'll get is t plus 4 multiplied by t plus 6, and it is equal to 120. On further simplification, we'll get t square plus 4t plus 6t plus 24 minus 120 equal to 0. This can be further written as t square plus 10t minus 96 equal to 0. Alright. Now if I split the middle term, the factors that I'm going to get are t plus 16 and t minus 6, and their product is equal to 0. Alright. So when the product of two factors is equal to 0, either of them can be 0. So when t plus 16 is equal to 0, we get t is equal to minus 16. And when t minus 6 is equal to 0, we get t is equal to 6. Alright, so I'm going to start with the first value of t, where we have t is equal to minus 16. We know that t is equal to x square plus 5x. So if I put the value of t as x square plus 5x in this equation, t equal to minus 16, I'll get x square plus 5x equal to minus 16, which can be written as x square plus 5x plus 16 equal to 0. Now if we calculate the d for this quadratic, we'll get d equal to 5 square minus 4 times 1 times 16, which is equal to 25 minus 64, which is clearly less than 0. If d is less than 0, we are going to get no real roots for the equation x square plus 5x plus 16 equal to 0. Alright. Now let's take the other value of t, which is 6. We know t is equal to x square plus 5x. So if I put t is equal to x square plus 5x in this equation, I'll get x square plus 5x is equal to 6. And if I take 6 from right hand side to left hand side, I'll get x square plus 5x minus 6 equal to 0. Let's calculate d for this equation. D will be 5 square minus 4 times 1 times minus 6, which is equal to 25 plus 24, which is equal to 49. As d is greater than 0, we are going to get two real roots for the equation x square plus 5x minus 6 equal to 0. Hence, we can say that there are going to be two real roots for the given equation, which is same as option C. So in this question, we have to find out all integral values of a for which the quadratic equation given by x minus a times x minus 10 plus 1 equal to 0 has integral roots. Alright, so this is the quadratic equation given to us in the question, and in this question, we have to find out integral values of a for which this quadratic equation has integral roots. That means it's safe to assume for this question that both x and a belong to the set of integers. Alright, because we have to find out the integral values of a such that the given quadratic equation has integral roots. Alright, so as we are dealing with integers, it's safe to assume that x and a belong to the set of integers. So if I take 1 on the other side, what I will get is x minus a times x minus 10 is equal to minus 1. Alright, if x and a belong to the set of integers, x minus a will belong to the set of integers. X minus 10 will also belong to the set of integers. That means we have product of two integers as minus 1. Alright, if product of two integers is minus 1, then there are two possible cases. First case is where we have plus 1 multiplied with negative 1. The second case is where we have negative 1 multiplied with positive 1. Alright, so there are two possible cases, and these are the two possible cases. Now from here, I'm talking about case 1 where x minus 10 is equal to minus 1. If I solve for x, what I'll get is x is equal to 9. If I substitute x is equal to 9 in the equation x minus a is equal to 1, what I'll get is 9 minus a is equal to 1, or we can say that a is equal to 8. Alright, so we have got integral value of x and integral value of a. Awesome. Now let's talk about case 2 where we have x minus 10 is equal to 1. If I solve for x, what I'll get is x is equal to 11, and put x is equal to 11 in the equation x minus a is equal to minus 1. What I'll get is 11 minus a is equal to minus 1, or we can say that a is equal to 12. As you can see, again, we have integral value of x and integral value of a. That means we can say that for this equation, x minus a times x minus 10 plus 1 equal to 0 will have integral roots when a is equal to 8 or when a is equal to 12. Alright, both the values of a are possible. Now let's see which option is correct. As you can see that option C matches with our answer here.